This is a good one. It says, evaluate and determine the limit does not exist for each of the following limits. It gives us a bunch of information based on this function. So now, the easiest way to do this is to graph it. And so I'm going to pull up my graphing calculator. Now you might say, Mr. Adams, how do I graph a piecewise function? Let me show you. Okay. Well, the first part of the function is going to be x squared plus, oh wait, you guys should be getting your calculators out and doing this as well. X squared plus 5. But now there's a parameter that is for x less than 0, right? So what I'm going to do is I'm going to open another set of parentheses and I'm going to say x, and I'm going to hit math. I'm sorry, hit second math because it's a test. And you're going to come down to less than, the less than symbol, or option number 5. Boom. And then hit 0. Now that's the first part. Okay? Plus, now put the second function, which is going to be 4, but you got to put it in parentheses. See, what I'm telling the calculator is graph x squared plus 5 for all values of x less than 0. Then graph 4 for all values, and then I'm going to say greater than or equal to. So I'll say x, go to second, then hit the math button, and it says test. And greater than or equal to is option number 4, so I'm just going to hit 4, and then 0. So put that in your calculator like that. And somebody had a question. What was your question?
Why don't you put it as a second y function? Why do you add it onto the first one?
Because I want it all one. If I put it as a second y function without the domain, the question is, why don't you just graph 2 separate functions? You can. But when I graph it as one function with domain restrictions for each expression, it's one fluid graph. Okay? If I do it as 2 separate functions, there'll be an overlap that could be confusing. There's no restriction on the domain for each expression. Does that make sense? So when I do it this way, watch this. Oh, let me change my window to a standard fit. 6. See how that did that? Now what do you guys notice right off the bat?
Jump discontinuity.
Yeah, discontinuity at x equals 0. So where's the issue on this thing?
It's jumping, man.
It's x equals 0. Now if we go back, so I guess what we're looking at is this right here. We have a jump discontinuity at x equals 0. All right, well that's not good. Well, what does it tell us to evaluate at? Well, it wants us to take the limits of this at all these values for d, and they said d is equal to -1. So if I want to know the limit of this as x approaches -1 from the negative infinity side, the only thing I have to do is pull up my graphing calculator, okay? And then I'm going to hit trace -1. Now what does that look like it's approaching? It's defined at 6, right? Or -6.
That's positive 6.
Or positive 6, I'm sorry. And if I go a little bit to the left, guess what? A little bit to the right. It looks like when you go to -1, it's gonna go to 6, right? So, okay, well that's good. So for this one, it looks like 6. Also, if I take the limit of this as x approaches -1 from positive infinity, and let me define that. I didn't do a good job of defining that. When I say from negative infinity, that means this is negative infinity, this is positive infinity. So when I take the limit as x approaches -1 from negative infinity, I'm looking at this way, this direction, to see what it's approaching. So in other words, I might start at, like, say, -1.01, which is a little more negative, and then zoom in on it. Another way you could do this is in the table. But I gotta define the table set. So let's start at -1, and let's make the incremental value like really small, like that. And so now when I hit second graph, if I scroll up just a little bit, if I come from the left, I'm coming from this direction. See my corresponding y values? What are they approaching? Well, they're getting smaller and smaller, and they're approaching 6. So that's where I get this, the limit of this is equal to f of x, is equal to 6. Now, if I say the limit of this as x approaches -1 from positive infinity, I'm just basically going to come down here and come from the other direction, right?
It's still gonna be the same, right?
And it's still going to be the same because it's getting closer and closer to 6, but it's increasing. Now, because the limit of the left-hand side and the right-hand side are the same, I can say with confidence that the limit as x approaches -1 of f of x should be equal to that same value, which is 6. Okay? Does that make sense? So now what we want to do is it asks us A, B, and C. Well, what's the limit? Well,
6.
it should be 6. So
Well, it's asking you to do it for just.
How can you determine C?
well, C is the two-sided limit. So if the left-sided limit and the right-sided limit is the same,
Okay.
then it should be the same for all three. So I'm thinking that it's C, right?